Hi there, as I promised before, I'm gonna break down the specimens paper released by the IB for the 2014 new syllabus. Okay, so I've looked through the paper. Honestly, all of the questions are quite interesting. Some of them are quite difficult. Overall, it's quite a hard paper. I don't know what's that gonna tell you about the new syllabus, because maybe just because the specimens, so they make it harder, or maybe it's really the IB is gonna tune up the difficulties from now on. I'm not sure, because honestly IB is not the hardest exam out there anyway. But anyway, I'm gonna start breaking down the question in the specimen. What I'm gonna do first in this video is I select all the questions that are on the new syllabus. That is, you would have never seen this question between 08 to 13 before. Alright, so this is the ultimate testament to the teaching of the teacher, to see if he or she is missing any topics. Because if you see the question that you have never heard about, well, that's a problem about your school. And honestly, there are some surprise. Some of them are quite under prediction. We kind of know, oh, that's kind of to be the limit of what they tell. But I'm gonna tell you the last question in the paper one, the continuity question, is just out of the blue. I don't think anyone would have predicted that the question would go that far. So anyway, let's get into it. Okay, I've selected basically all of the new questions, just kind of all about the paper one. Paper two is kind of more normal, except maybe one or two difficult questions. Okay, so anyway, we're gonna focus on the paper one first. I've selected 4 questions that are on the new syllabus. They're totally new. I haven't seen this before. As what I mean before is between 08 to 2013. All right. So the first, okay, rightfully, is about sum of root and product of root. Okay, this is specified in the syllabus quite, frankly, quite clearly. So nobody should miss it. So A is pretty easy. Just write down the value of the sum of root and product of root. Okay. So if you haven't noticed, you really should listen about this. Okay. You have a polynomial. So this is polynomial of degree 3. So we're gonna call the number in front of x cubed a before x squared. This is b, c, and then d. Okay, and then the sum of root. The sum of root is pretty easy. The sum of root is always negative b over a. Okay, this is something you know. This is something you should remember. The product of root is the last one. Okay, so it depends on the power. This may be e, this may be c. I don't know. It's d over a. The last one over a. Except you have to be careful with the sign. Okay, for the sum of root one is always negative. Then the next one is positive, and this one is negative. So for this time, it's negative d over a. Okay. Now what do I mean by this? Right? If you are doing a quadratic, ax squared plus bx plus c, what is the sum of root? Sum of root. The sum of root is always negative b over a. So we always start with negative. But what is the product of root? The product of root is the last one over a, so c over a. And then since this one is negative, the b one is negative as always, the next one is positive. Therefore the product of root for quadratic is positive c over a. Okay? But for cubic, it's negative d over a. So you may be guessing, okay, what about for quartic? What about for a power 4 polynomial? Okay, it would be e over a, and this time it would be positive. Okay, so it's alternating. Alright, so that's an important thing. So part A. After we know this, it's pretty easy. The sum is negative b over a, so it's negative 45 over 9, it's 5. The product is negative d over a, d is negative 40. Oh, I missed that negative here. Over 9. Okay, so it's 40 over 9. Okay, so B. Okay, they're telling you that the roots are 3 consecutive terms of arithmetic sequence. Okay, so what do they mean? That means they differ by the same amount. Okay, the common difference. And they give you a huge hint. Just take the root. It will be alpha minus beta and alpha plus beta. What do they mean? That means if you list out all the roots, it will be alpha minus beta, the first one, and then alpha plus beta. You should be able to see that this gives you an arithmetic sequence. What is the common difference? The common difference is beta itself. Okay, so from alpha minus beta, you add beta, you get alpha. Alpha plus beta, you get alpha plus beta. So this really form a arithmetic sequence. Okay, it is really kind for the IB to give you this hint, because if they don't do this, just by saying arithmetic sequence, I predict a lot of you would do A plus D, and A plus 2D to represent the 3 roots. I really encourage you to try at home and see how difficult that is. Okay, it's doable. It's definitely doable, but it's much harder. Okay, what about this? Why is this so good? Because we're gonna use the sum of root. What's the meaning of the sum of root? We add them up. So it's alpha minus beta plus alpha plus beta. Okay, it's supposed to be 5. What is so good about this? Minus beta and plus beta automatically cancel out. So it's 3 alpha equal to 5. Alpha is already 5 over 3. Alright. What's next? We need the product of roots. So product is we multiply them together. So a plus b times a minus b is a squared minus b squared. So this is supposed to be 40 over 9. But we already knew the value of alpha. Multiply on this side is this. 25 over 9 minus beta. Therefore, beta squared equal to 25 over 9 minus 8 over 3. I predict if you're an HL student, you should be good at numerical calculation of this. So I just show the process quickly. Okay, so alpha is eventually plus or minus 1/3. Okay, does that mean that we have 6 different answers? Not really, because alpha is 5 over 3. Alpha is 5 over 3. If you take beta to be plus 1 over 3, then you will add 1 over 3 and minus 1 over 3. But if you take beta to be negative 1 over 3, the negative, positive, and minus, they will really give you the same answers. So the question asks you to solve the equation. That means you need to write down all the roots. So the roots are 5 over 3. 5 over 3 minus 1/3 is 4 over 3. And also 6 over 3, which is 2. So that's it. The first question on sum of root, product of root. And they only ask you the sum and product, but not the middle term. If you don't know what I mean, sum means you add them all up, right? Product means you multiply them together. I don't know if you know there is a middle term. The middle term is you multiply 2 of them together, and then add them up. Okay. I think most teachers would have predicted that this wouldn't be tested, and it happens to be true in the specimens, so we will see. So this is the first question I want to talk about. The second one asks about properties of function, whether the function f is even or odd or neither. Okay, first of all, do you know what this means? Alright, if you haven't heard of this term, then goodbye. There's no chance that you can do it. You can just, forget about part A. It will happen that even if you don't know part A, you can still do part B. Of course, it's differentiated, and most likely you can still do part C. So you just lose 3 marks. Okay, so let's talk about it. What is the meaning of even function and odd function? Oh, sorry for that. Technical problem again. So by definition, even function are functions that if you consider f minus x, so you input minus x into f, it will happen to be the same as the original function. So f minus x equal to fx. For odd function, is if you input negative x, it would just be the same as you negative the whole function. So this is an odd function. Okay, if you satisfy this, you're even. If you satisfy this, you're odd. If you satisfy neither, you're neither. You are not even nor odd. Alright, is that clear? So how do you determine if a function is even or odd or neither, right? You just consider f negative x. So that's part A. We consider x. So this is fx, so we do it cosine negative x plus negative x sine negative x. Okay, and if you're good at trigonometry, you should know that cosine negative x, okay, for cosine can just eat the negative. So it's 2 cosine x, okay, minus x. What about sine? What do sine do with the negative? It will take it out. So it's plus sine x. Okay, is that clear? Okay, you should really know these identities. Okay, and you may ask, what about tangent? Well, tangent will also take the negative out. Okay, the reason behind this, usually we explain this with the cast diagram. Okay, so you want to check out your trigonometry if you don't know this. Okay, so what about this? If you look at this, this is exactly the same as the original function. So this is fx. Therefore, f negative x is the same as fx. Therefore, by definition, this is even. Okay. Part B is quite straightforward. They want you to differentiate 2 times, plug it be 0, and show that it's actually 0. So fx, copy fx in. So what we do is we differentiate this, right? So f prime x. Differentiate cosine is negative sine. This is x times sine x. So you will need product rule. We do product rule here. So we copy the first one, differentiate the second one, plus differentiate this one, which is 1, copy the second one. Okay, differentiate it. Double prime, the second derivative, right? Differentiate this again, differentiate sine is cosine. Product rule again. Okay, so minus differentiate cosine negative sine plus differentiate x is 1, so copy cosine plus differentiate sine cosine. Therefore, the cosine plus cosine is 2 cosine. 2 cosine minus 2 cosine is 0. So minus x sine x. You plug 0 in. Okay, obviously this is 0. So shown. Alright, part C. Some guy John stated that simply because the double prime is 0, the graph has a point of inflection at the point 2, 0, 2. Explain if this is correct or not. Okay, you may think maybe the 2 is wrong. It happens no. If you plug 0 in, you actually get 2. So the y is actually 2. So the question is simply because that the double prime is 0 doesn't mean that it's already a point of inflection. Alright? Of course, the answer is no. What do you normally do? Right? What you normally do is you need to do the side diagram, do a side test. So we know that the critical one is 0. We need to try something bigger than 0, try something smaller than 0. You need to plug it into the second D to test for point of inflection. Alright? So at x equals 0, we already know the second D is 0. So we try, okay, maybe 1. Okay, remember, yeah, whatever. You just try something bigger, try something smaller. Then into the first derivative, so it's here. Then you'll see if there is a side change. Alright. The problem is, we don't really have a calculator. So you may think trying numbers seems a little bit difficult. Well, it's still doable, but it happens that for this question, there is another way. The way is, well, the function is even. The function is even. What does that mean? The meaning of even function is such that for the negative part of the graph, if you negative x, the functional value, when you f it, f means the y value, right? So for negative x, the y value would really be the same as the original x before you negative it. Okay? So what it means is, whenever you have an even function, the graph is always symmetric of the y-axis. Why? Because the positive x part and the negative x part takes the same value. That is, say this is 3, right? Let's say when x is 3, y is 2. Then what about negative 3? Then since it's even, right? So they will satisfy this. Therefore, f negative 3 would really should be the same as f3. Therefore, they would have the same functional value. If you continue this, then no matter what the graph look like, the other side would just look like exactly the same. Oh my god, I give myself a hard task. Okay, roughly like this. Anyway, across the y-axis, the thing would really be symmetric. Okay? What do they mean? What does this mean, right? This basically means that there couldn't be any point of inflection on the y-axis. Okay? Because what is point of inflection, right? Point of inflection need a change of concavity. That is, for the point on the y-axis to be a point of inflection, you need, okay, before it to be, say, concave down, and after be concave up. That's the meaning of point of inflection, right? You change concavity. It's either this or the other way around, so something like this. Sorry, not this. Like this. So before is concave up, after is concave down. Okay? But our function is symmetric. Left to right is symmetric. That is, these kind of cases just couldn't occur. Okay? Because this is not symmetric anymore. So just because of this, that point on the y-axis, okay, 0, 2 is on the y-axis, right? 0, 2 on the y-axis can never be a point of inflection. Okay? Therefore, we will withhold this. We probably won't do the side test. Okay? And say since f is even, okay, the graph is symmetric of the y-axis, and therefore the concavity must be the same across the y-axis, and hence no point of inflection. Therefore, John is wrong. Okay, therefore John is wrong. Okay, this is it. I can still try to do the side test. I believe they would still have to give you the mark if you fill in the side graph correctly. And if you see when x is positive, this is positive, side some little positive. When x is between 0 to pi over 2, between 0 to pi over 2 is positive, so this is positive. While when x is negative, side that thing would be negative if you are good at cast diagram. While x itself is also negative, so negative, negative. Wait is that? Like this side graph. So this part is negative, negative, negative. Oh no. It was positive. It was negative because this is positive, this is positive, this is negative. Okay? So the side diagram would really be negative, 0, negative if you would try to do it. Alright. But anyway, just for the function being even is enough to tell there is not a point of inflection. Okay, it's a long video. Let's move on. Okay, the next question is about this. It's about a system of equation. You may say, oh wait, this is not new. We used to have this. Well, yeah, we used to have this kind of question, but now matrix is out of the syllabus. Therefore, you are not expected to use matrix or determinant to determine, okay, when do the system do not have unique solution. In the past, we would just calculate the determinant of this matrix and say when is this 0, right? If you don't understand what I'm talking about, that's good because, well, matrix is not in the syllabus. So how do we do it now? Okay, we do something called row reduction. Okay, I quickly show you one. Because one example is really not enough to show you how this row reduction is supposed to work. So I just want you to see if you knew this. If you don't, you should probably ask for some help. Okay, so this is what you do. Our job is to change this matrix into this. So these are numbers, right? So I don't know what are the numbers gonna be at the final version. But what I want is I want this to be 0, 0, 0. The rest I don't care. Okay. So the main point is I want these to be zeros. So this is what you do. We usually keep the first row, and then you think about how do you make this 0. We're going to do that by something called row reduction. That is something similar to the method of elimination when you are doing simultaneous equation, the two equations, two unknowns. So we're going to multiply the first row by 2, and then subtract. Right? If you multiply by 2, it's become 2, 2, 2, 2. So 2 minus 2 is 0, 0. This is become 2, 3 minus 2 is 1. This is 2, right? 1 minus 2 is negative 1. This is 2, 3 minus 2 is 1. And then again, this is 1, this is also 1. So we can just subtract, okay? 1 minus 1 is 0. 3 minus 1 is 2. Negative 1 minus 1 is negative 2. Lambda minus 1 is lambda minus 1. Okay? We shouldn't draw equal sign. Okay? So next, we need to make this 0. Okay? These two are already 0. So you're going to make this position 0. So what we do is we want this to be 0, so we're going to multiply this row by 2, and then use this subtract that. Okay, so 0. Multiply this by 2, that's negative 2. Negative 2 minus negative is 0. This becomes 2, so is lambda minus 1 minus 2, lambda minus 3. Okay. And what you want to show is the system do not have a unique solution for any value of lambda. Now this is true. Why? Because this is all 0. Okay? Whenever this is all 0, then there is no unique solution. Okay? Therefore, no unique solution. The reason why this is enough to show that there is no unique solution will really take another video.